All right, so hi everybody, I'm Andreas, unfortunately not Dominic. He's busy with preparing a talk for the IAA tomorrow, and then he's flying out to China on Friday, so not that much time, unfortunately. Anyway, I'm going to talk to you about IOTA, tell you roughly what IOTA is if you haven't heard about it yet, or if you haven't heard about how it actually works, and then I'm going to go into some more detail on use cases. And give you some insight of what kind of stuff you can actually do with IOTA right now without future developments. So first of all, what is IOTA? We always call IOTA a blockchain without the blocks and without the chain. A blockchain is actually a subset of what you can do on top of a DAG, which is what IOTA is based on. IOTA, if you look at the network and at the transactions, pretty much looks like this. This is what we call a tangle, and each node that you see here is essentially one transaction that always references to previous transactions, going this way. There's also a white paper that describes the tangle and IOTA. Go look it up, just Google for it if you want to. How do you make a transaction? There's essentially 3 steps. First of all, you need to sign your transaction, as you pretty much need to do everywhere in each cryptocurrency. Then you need to do a tip selection by using Markov chain Monte Carlo walks. So essentially, there's some probability involved of which other 2 transactions you're confirming. And at the end, once you've selected those 2 transactions, you need to do some proof of work, just so that your transaction gets accepted by the network. And so we can make sure, or rather that the network can make sure that you don't do any spamming and that you don't flood the entire network. So why is IOTA awesome? 2 or 3 takeaways. First of all, there's no transaction fees. There are no miners. There's nobody who needs to get paid, because if you want to do a transaction, you do all the work you need to do yourself. If you send somebody a cent, the other person receives the cent. As easy as that. And then the more people you've participating in the network, the more nodes you have active on the network, and the more transactions you have on the network, the more transactions get confirmed and referenced and therefore accepted by a network. So the more users, the more scalability, the higher we can scale. And it's fairly similar to horizontal scalability instead of something more vertical. IOTA is essentially backed by the IOTA Foundation, which is a not-for-profit organization based out of Berlin. If you've heard one of us talk about IOTA before, you might have heard that we've been saying this. We've been in founding for months now. We will be finally finished founding ourselves this month. Everything's finally in order. It took us way too long, too much cash as well. But that's the way it works in Germany, I guess. Because bureaucracy, well, hello. But essentially, something I want to say about this is the foundation is entirely founded by our tokens. There's no fiat involved here, so this made the whole process a bit more difficult as well. Now, what can you do? Some rough developer introduction. Let's see. Let's first talk about IOTA's main features. The first main feature is data security. It's a cryptocurrency. You want to store your data in some encrypted sense. So it's everything is either cryptographically secured and signed or otherwise encrypted. And the main goal that we're aiming for is machine-to-machine payments. In the future, when you have your kitchen, you maybe want to have your fridge paying your electricity provider for providing the energy that it uses, and similar. And once we've done these, I actually can talk to you about some of the upcoming features that we're working on, and this is one that we're going to be releasing this week, finally. It's called a Flash Network. It's essentially off-tangle transactions without having to go all the round trip to the tangle. So the way this works essentially is that you've got multiple parties who essentially do bundles of transactions and co-sign these together. And so you do each transaction you do in this off-tangle network essentially is a bunch of transactions. And then at the end, when the whole network is done, when the whole off-tangle exchange is done, you can just submit everything to the tangle and end up with transaction that you didn't have to published before. We'll be releasing this week, and there's also a proof of actually a use case that we're going to be releasing with this, which is in collaboration with Satoshi Pay. So if you want to think of Flash, then it's more like a very use case specific application protocol on top of IOTA. It's not as general purpose. And you can essentially have high frequency value transactions without interfacing with the network. Yeah, that's a rough design of the architecture there. Essentially, for this use case, you have a round trip via server which you need to, which validates that you're actually paying for something, and then the server releases content to you. I guess it's somewhat similar to pages like Flutter, where you do microtransactions for rewarding other users. Something else that we're working on, which is built on top of this, is called MAM, Mask Authenticated Messaging, not messaging. And it's essentially secure, authenticated, and authenticated symmetric encrypted data streams. So think about it as, encryption running on top of the tangle with quite a few very necessary promises and features built on top. Use cases for this is probably easier than explaining how it works. Stuff like Industry 4.0, where you can have where you can control machines from a central hub, and at the same time have an audit log of what's actually happening there. This is essentially something that we built in collaboration with a partner. You'll probably hear about that sometime soon, where you control a machine on the factory floor via MAM by sending encrypted messages across the tangle to that machine, and then also get everything back, and there's an audit trail because everything's published to the tangle. And there's some other use case, something that you can try out right now as is, which is called, which is in collaboration with this Finnish company called Ruvi. They've got this very nifty little IoT sensor kit. It's got temperature, humidity, and similar. And MAM is running on top of that to publish transactions to the tangle. So that, for example, you could authenticate, you could publish all the sensor data to the tangle in an authenticated fashion. And finally, this is something that you might want to look out for. This is a data marketplace that we're going to be releasing next month. We've got about 20 fairly large companies on board with this, and it's essentially about enabling machines to pay other machines, or users paying machines for accessing their data. Thank you. I thought that.
That's me. Yeah. Good evening. My name is Carsten Stöcker.
Oh,
yes,
damn.
It wasn't done yet, but anyway.
Yeah, I just noticed as well. That slide, I'm quite sorry, that slide is actually about an IOTA ecosystem fund, and I just lost my mic. Which is essentially, if you've got an awesome idea that you want to develop on top of IOTA, there's the ecosystem fund funded by the community. Submit it, maybe we can see to get your idea developed. Now, thank you for real.
Wonderful. Yeah, my name is Carsten Stöcker. I'm working for innogy. Innogy is a big utility. We are operating renewable power plants. We are operating large distribution grids to distribute electricity to households. And we are doing retail. In addition to this, we are also doing innovation, because we know everyone is going the energy business. We'll be pretty much competitive. A lot of disruption is going on. And we would like to prepare ourselves for the next new sustainable business models. One of the areas we're doing is called machine economy. And today we would like to introduce what are we doing with IOTA in the machine economy area, because we think it's a fantastic young technology that has a lot of potential to build completely new business models. And we're looking into this. Innogy Innovation Hub, what we're basically doing is you can go to Silicon Valley, go to the Singularity University, and they will teach about exponential innovation at the edge, which means you leave the core business of your company. This is what our Innovation Hub is doing. It's at the edge. We're looking into new business models in the energy space, in adjacent industries, in other industries, so we can do this. and also would like to find a new business model that's scalable. What does it mean in innovation? We have a couple of focus topics. We call them lighthouses, smart connected lighthouse, digital disruption, urban solutions, and one of them is machine economy. That's what we introduced today. We have a couple of outposts. That's very important for us because we are engaging with startups, with ecosystems. We are building ecosystems for the next fourth industrial revolution on decentralized technology. And outposts are in Tel Aviv, in London, in Berlin, and in Silicon Valley to really get relationships with the very best dealing with new technology. And of course, for us, I think it's a gift for Germany that one of the most important locations in the world is Berlin, because we have so much knowledge, so much innovation. It's a gift that's all happening. A lot of that is happening in Berlin. Network partners, that's what we do in Innovation Hub. Machine economy, you can say, okay, it's IoT devices, cyber physical systems. A lot of people have started work on cyber physical systems when machines are doing transactions among each other, and a manufacturing machine, a testing machine, a logistic transportation machine. It's nothing new. Bosch, Siemens, all the big companies, IBM has invested quite some money to build their IoT platforms. We don't want to compete with them. We're only looking kind of machine economy, IoT use cases on decentralized platforms. And for us, that's blockchain, peer-to-peer communication. It's a mask authentication messages that we just heard. It's IPFS, Big Chain DB, IOTA. So basically combining these technologies to build real decentralized platforms for the future that can automate quite a bit. And that will end up with a new customer group that we'll introduce shortly. Good agenda, fourth industrial revolution, why it's important for big corporate. Then we would like to introduce digital twins. We show some live transactions on the IOTA tangle in a couple of minutes that you see. It's not PowerPoint, it's happening in reality. We will talk about electric vehicle charging and token streaming. Everything what was introduced by Andreas, you see it in real life use case, how it's being done. It's not only innogy, it's a couple of other people. I will introduce some other people later as well. Yeah. Good. Fourth industrial revolution. I say innogy, it's a very important technology. It's worth to know because you probably read about the MIT report. Is this responsible or not? Hash functions, differential cryptographic analysis. These are kind of points they raise. However, it's important. It's a young technology. It's a technology with super huge potential. And if there's a bounty, such as a big market cap, and you get some publicity, of course it's fine when people test it, attack it, because only with these things the technology is maturing. And so we are not naive at innogy, so we're not recommending kind of to buy a new cryptocurrency or something else. We take it seriously. So we're also working with some of the world-leading cryptographers from UC Berkeley, for example, reviewed hash functions, discussed this with the team, and the points addressed by MIT, a lot of them were already addressed, or even all of them. For that reason, we think it's a young technology, it's promising potential, and right now is the time to test it, to prototype it, and to make sure it's continuing to mature, that's being used in real systems and use cases. Good. Fourth industrial revolution is a very big use case. For us, it's a fusion of the physical world with all the machines, objects, IoT devices, the digital world with all the software and bots, and the biological sphere. So all these spheres are now merging and converging. And for us, that's a big opportunity space. We only looked in terms of identities, so giving identity to 3D printed object, to an autonomous car, to a weather station, whatever it is. It's providing identities to objects. There are 24 billion RFID tags. There will be 20 billion IoT devices and QR codes. So it's super huge, and we connect identities of things with a digital representation that we call digital twin, and we will demonstrate in the next minutes what's the role of IOTA in this game. I mentioned decentralized platforms, so we are only looking at our machine economy lighthouse in physical use cases, or primarily, which means exchanging energy, providing mobility service, manufacturing goods, providing telecommunication services, all these kind of physical things, combining this with IoT to make sure that we have automated, decentralized systems in the future. For us, blockchain is a synonym in terms of decentralized storage, databases, off-chain computing, a lot of super fantastic modern cryptography, and that's the space where we're working. It's not only innogy, it's an entire ecosystem. It's people in Berlin, IOTA, and this will be very powerful. One of the key things why it's called machine economy, because when I started 3 years ago doing blockchain, IoT in our innovation team, the kind of the core principle was technology is given. We don't do R&D. We don't even look into technology. And this is when people said you have to do your customer insights, human-centered design thinking. I hated this because if you go to the people and try to engage them on blockchain, cyber-physical systems, you get no insights at all. And then the project will be stopped. And that's the reason why we invented a very nice concept to kind of have some counter-arguments. We basically said, hold on a minute. There are 2 types of customers today, individuals, as we all are in this room, then businesses, B2B, business among corporate, and now the third category is machines. So we really believe machine is the third category of customers, machines driving purchasing decisions, machines doing economic transactions among each other, and here's a little explanation what it means. Machines might be owned by a person, but you can tokenize it, and then many persons own it, or other machines own it, can be self-owned. All kind of concepts of ownership will be changed as well. But regardless of ownership, a machine is a couple of actors, sensors, has a little bit of embedded computing, some algorithms, and now we attach an IOTA node to the machine. I think most of you who are in the blockchain space are pretty aware of the concept, but I like to share it anyway, because if you put a blockchain node or an IOTA node inside the machine, the first thing what will happen, the machine gets an identity. So it has in an ordinary blockchain world, it's a public private key. The public key is being published on the blockchain, that's the identity. So the machine gets an identity, and now we are able to do know your customer, what the banks are doing, but with machines, and that's called know your machine, know your object. It's pretty important, because today it's the identity of machines, pretty unsolved problems. In some cases, they're even clonable, or there's some other attack vectors. And together with blockchain, giving an identity to a machine on an interoperable ledger or technology, it's super powerful. What else will happen? Machine has an identity, machine gets a wallet, which means machine can receive tokens or cryptocurrency for services it's providing to others. It can pay cryptocurrency or tokens for services it's consuming, such as basic needs, energy, connectivity. It can pay for the services. And in the end, the machine with the wallet has its own profit-loss statement. The machine is its own micro-organization. The machine is its own economic independent entity. And that's what we call a machine customer, because can do economic decisions, transactions, everything is nicely set up for this new type of customers. In addition, cybersecurity, we heard a little bit with the mask authentication messages by Andreas, what happens as well. With blockchain, I can give data. I'm taking out of the machine a fingerprint that we call hash, which means when the data are being sent by the machine to me, I'm now sitting in China, the machine is here in Berlin, I can compare the hash, look it up in the tangle on the blockchain, and then I find out the hash is still intact, correct, so no one has tampered around with the data on the way from Berlin to China. And in addition, so I can really authenticate the machine. I know is the data coming from the machine and no message injection by someone else trying to attack the system or the correctness of the data. Interoperable transactions, the Ethereum people, they have the smart contracts, and then they talk about sharing economy with smart contracts and blockchain. You can do asset sharing, ownership transfer, all this kind of stuff. And of course, there's also a development roadmap in place to enable similar things with IOTA in the future. Digital twins, why are they important? It's a digital model of a real-life object or machine. You can think about a 3D printed cufflink. With a 3D printed cufflink, when the manufacturing order comes into the decentralized manufacturer, an identity is being set up. It's the manufacturing parameters, the test data, the quality assurance data being stored in the digital twin. It's being stored how it was used, transported. I lose one of my cufflinks, then I need batch size 1 production, which means I need to produce another cufflink. I still have the manufacturing parameters, send it again to a decentral 3D printer. The new cufflink is being produced, and everything is fine. And all this kind of stuff could be done with the concept of a digital twin, when a physical object has a digital representation telling the story of an object from the manufacturing orders that came in until it's being recycled and the raw material are being extracted. And so it's one of the core technologies of Industry 4.0. You're probably aware of Professor Waldster. He was the inventor of Industry 4.0. If you look at his slides, what Industry 4.0 is about, digital twin is a core component. There are a tremendous amount of use cases in this area. I just mentioned a few. Problems to be solved, today, fake trust, no trust, fake products, whatever it is. What you basically do, you can produce a product, you tag it, then you sign the identity. Let's say it's an Adidas shoe. Adidas produces it. It's being tagged with a crypto chip. The identity is put on the blockchain. The identity is signed by Adidas. So when I then approach my turn shoe with my mobile device, I send a transaction to the crypto chip. It's being signed by the crypto chip. I look it up, the identity on the blockchain. I find out it's being signed by Adidas, and then I know, okay, this shoe was exactly produced by Adidas. So basically, digital twins and modern cryptography are solving a big problem in terms of fake products and product piracy. Lack or tampered data, mentioned this briefly, message injection, man in the middle, can be all avoided. And in the end, so if you think about, let's say, a fleet car, a lot of users, a lot of stakeholders are engaging with a fleet car. It's a fleet operator, it's the driver, it's the maintenance shop, it's insurance. And if you put a couple of this data in a digital twin, you first can get an auditable record about, let's say, mileage. How was the car being driven? Short distances very often, long distances not so often, because all this data about the car is pretty much important to understand the remaining value of a car. And of course, if you sell it on, today it's completely unclear. 1/3 of the cars have tampered mileage data. Can I trust the car? Can I trust the data? So with this technology, you can start trusting the data and the information about the car. This has a huge value in the second car market, but also have a huge value if you think about a company leasing machines. They immediately know what's the remaining value, was it maintained correctly, and all the other things. Big improvement. Restricted access. So we have, for example, digital twins today as well. In Bosch, in Siemens, in the cloud. They produce the component, put up the digital twin, but in the end, when the component trails along the supply chain, it's very unlikely that the next company, the next customer, the next something owner of this object will reconnect back to the digital twin of the original equipment manufacturer. And that's quite important because if they don't connect, the digital twin is worth nothing. And we think we put it in decentral technology, put some proper key management, access management on top of it, and then we have interoperability, and suddenly the original concept of digital twins, which are core components for Industry 4.0, are valuable and practical in use. In addition, there's a lot of innovation around these concepts. One of the key concepts we like, we take an object, such as a bag for women. Usually, if you go to the store, you buy the bag, then the retail store is asking you for customer data. You have to fill out your loyalty cards, hand over your email address, and then the shop owner knows who you are. With this tagging object, the object has an identity. I sell the object. As a manufacturer, I still know which object did I produce. The new owner of the handbag is registering the newly bought object in this little object wallet. And then without knowing the customer, the manufacturer can still communicate with the object. That's what we call object marketing, entirely new kind of marketing concept, because today we need to abuse the privacy of the people who are buying stuff. In the future, we don't need to abuse them. We communicate with an object. Even if the object is changing ownership, it's being handed over to a new owner, we can still communicate with it. have proper, entirely new marketing channel. It's just kind of opening shots that a lot of new innovation is possible with this technology. What do we do? So I personally be one of the biggest fans of BigChainDB. We say, yes, let's do this. Do a representation of physical things, objects, and machines. Set up digital twins. So we do it in BigChainDB. A lot of people are doing this on Ethereum. They put their mileage data on Ethereum. It's expensive, and of course, you cannot put much data on Ethereum. But with a scalable blockchainified database, you have all the advantages: immutability, decentral database to set up digital twins, not in the cloud of the OEM, but in decentral technology. And then we tag the objects. You can tag the objects with secure QR codes, with crypto chips, or with IOTA. And that's what we are basically doing. Another picture of the platform. Basically, object, platform, data storage, and a little bit of user experience, analytics, dashboards on top of it. But so we are introducing IOTA to tag machines with embedded computing, because when we tag the machine with an IOTA node, we get an identity. The machine has an identity, we're tagging it, cryptographic identity, and of course we have some data authenticity and integrity, and that's what we show next. One of the things is the, Andreas mentioned this as well, message publication channels, and that's pretty nice, because now with IOTA in the machine, I want to get my data out of the machine. I would like to make sure the data are encrypted. I would like to make sure that the data is exactly coming out of this machine, not a third party, no message injection, no man in the middle, nothing else. And I would like to make sure that the data are not changed. And what we basically do, we connect the machine with IOTA to the tangle, use the new protocols, transport the data into BigChainDB, and then we can be sure that the data coming out of the machine are exactly the data we have in BigChainDB. And we can look in some live transactions. Dimi, should we do it now?
Good.
Yeah. So it's real, so it's not just PowerPoint. It's basically we are building the stuff, the platform, together with colleagues from BigChainDB, Dimi, and we integrated IOTA. It's working.
All right. So what you see here is an example of data being posted by a BMW. Every time you start and stop, the BMW actually sends some data to the OEM, but in this time, we're going to send it to IOTA and BigChainDB. IOTA will intercept the machine, the information at the machine level, and BigChainDB will put it in the database in a structured way, so that you can query it afterwards. You have human interpretable code. So let me just hit that button. So I'm sending it. What you'll see is things happening in the background, all nerdy code, sending transactions to IOTA. I actually am using a node from this guy there, so thanks a lot. So this might take a while. It takes about a little minute, but I'll show you an intermediate result. So this is, once a transaction gets published, it first enters BigChainDB and then starts tracking the IOTA progress. So what you'll see in this transaction is that actually it links to an IOTA transaction. So we can just fetch this transaction, look it up in the tangle, see if it actually exists. And it actually exists. So this means that we basically managed to create a system where you have a machine layer information and you have a structured database that can act as a permanent node for IOTA storage. One thing you should consider when playing with IoT devices or hooking them up is they're not really built for big data. They're built for their own purpose in the machine. So BigChainDB acts here as a general data center to organize the data of IOTA. So how does this look for an end user? So we use this in... Are you talking about this, Carsten?
Yeah, no, you go ahead. Yeah, perfect. It's real. We have real cars on it. Yeah?
So we have a few live cars running on this system. Some BMWs from test tracks, even some TomTom device. And basically what they are doing is they log the trips of the actual usage. So this gives insight in where your car has been at which point in time. Now it becomes a bit freaky once you start clicking on these things and you actually see where the car is driving at this point in time. But this is for example, a private view that you as a car driver would only see because you have the rights and permissions. Now I hacked the system a bit, so I'm an admin and I can see everything. It's good to be God. But for example, if you're a fleet manager, you're not, well, data privacy and such aside, but what you would
We fix this.
what you would see is some aggregate data, maybe some analytics, some statistics you draw out. So this is actual mileage reporting. So try to fraud this. It would be very difficult because we have to rewire the tangle, BChainDB, others. Here you can see about where it has been driven. Has it been driven on the German autobahn? Then I wouldn't rebuy the car too much. But anyways, this gives you a bit of the human view on the data we are gathering. And that's all for me.
Yeah, perfect. Wonderful. Thank you. The tangle in action. Fantastic. Yeah, that's what do we have here? Here it is. Basically, yeah, we are using the protocol to get the data out of the car, put it in an immutable database, and then to make sure we can trust the data, and all kind of stakeholders can then use them for the different use cases along a supply chain or product life cycle. This is what we have seen. The other use case, it's electric vehicle charging. It's a very nice comparison also against Ethereum a bit, because this is Andreas Antonopoulos. You probably know this. He basically said in his book Mastering Bitcoin, hey, let's mesh Bitcoin, Uber, and self-driving cars. What happens? Again, we have the economically independent device, economically independent car. He's basically talking about the self-owning cars that owns itself, can pay the lease, can pay the charging, can make revenues with kind of renting it out for ride-hauling. This is the basic idea. In principle, now the car is interacting with the real world, and I think mentally it's always good to have a very simple model in mind. So it's Alice in this case. It's the autonomous car. Then we have a charging pole. That's Bob. Bob is providing energy to Alice, and then with Bitcoin and Ethereum, yeah, Alice can pay in cryptocurrency more or less in real time at the charging point. Interoperability. We don't need to put any contracts in place. Two parties, a car and charging pole, that have previously never met. They don't need a contract. They don't need master data and big expensive SAP systems. They basically need an identity on a decentralized ledger, connect to each other, and can do a direct counterparty transaction with this technology. Yeah, I think it's worth to mention that in this single transaction, 3 industries are converging: financial industry, banking, payment, utility industry, and mobility industry. And now the big question, who's making money with it? Anyway, the margins are being reduced. It's more or less going to zero marginal economy. In terms of business case, yeah, no one knows what the business case is, but at least technology will work. Somehow, someone deleted my Ethereum slide, because basically, yeah, that's now the IOTA slide. Basically, how does it work? So we have the charging pole here. We have the car. No, that's a charging pole, that's a car. The car with Ethereum is basically doing escrow payment. It's doing a little bit of prepayment for the charging into the smart contract. The smart contract acts as a notary, basically telling the charging pole, hey, Bob, there's money in the smart contract. You can start the energy charging to the car. The charging pole then knows, oh wow, there's money. I can, without any credit risk, I can start the charging process. And the car knows, or Alice knows, okay, if Bob doesn't charge my car, I will get my money back, because the notary on the blockchain smart contract is basically paying me back. If you implement this in practice, we have done this, it's working, it's nice. But with the smart contracts, it's a little bit sophisticated, and we like it to have more easy. Real-time token streaming, I would say it's in concept phase, and Harm from Enexis and ELAT in the Netherlands is implementing this already. By the way, Harm, what are you doing there? Do you need a mic for Harm? Yeah. Harm.
Okay, thank you. This wasn't planned, but
we are spontaneous.
Yeah, we actually we are building a charge point which has its own IOTA wallet running on itself. So it has the IOTA wallet running, and as a user you can send your IOTA towards the charge point. So you don't need a backhouse for the charge point, you don't need any protocol for the charge point, it just runs on IOTA. Also the measurements from the energy usage from the charge point, for example, these are stored in the tangle. So you can, like with the kilometers you saw, later on just check and see if the kilometer or if the kilowatt hours used are somehow logical. The other thing, and that's what I really like, is also all the user communication. So the communication towards the one sending all the IOTA tokens is done via the tangle. So all the information sent is done via the tangle. There's no need for any new or different API. Everything is done via the tangle, and that's I think a really cool use case.
Yeah, I love it. Yeah, and so for us, it's innogy. So everyone is doing peer-to-peer energy trading on the blockchain, which means one neighbor with a solar cell is selling energy to another neighbor. You can do this. A lot of people love this because then we have energy cooperatives living on the blockchain. It's a little bit a challenge because the challenge there is there's not technology penetration in terms of smart meters. In Germany, we have not much smart meters, batteries, solar cells. It's a regulatory issues and it's no economic incentive because renewables are subsidized. And that's the reason why at innogy we said, okay, let's look at another use case, and we ended up with electric vehicle charging. It's a super simple use case. We built the system, and now we are looking in terms of to improve the system. It's a very basic chart. So we love the real-time token streaming feature of IOTA. Andreas introduced it as flash channels, where you can immediately validate a transaction. So if you trust the charging pole, you can even do it without the flash channels with IOTA. But anyway, so what IOTA is doing, it can stream nanotokens. I have a watt-hour or small energy package. The charging pole is delivering a small energy package or stream of energy, a load current into the car. The car is measuring the small energy packages, and then it's releasing small nanotokens and sending it via the tangle to a charge pole. In the charge pole is a control unit, figuring out if the energy is kind of in sync with the tokens it's receiving, which means I charge the cars with a couple of watt-hours in the last couple of seconds. And then the charging pole is figuring out, are the payments in sync? Is it balanced? And with this simple feature of a synchronized energy streaming and real-time token streaming, we take out any credit risk out of a transaction. We take out a lot of complexity, and that's the reason why we love this this technology. Of course, we know probably have to prove it and test it and prototype it properly, and we need to engage with further further cryptographers to make it bulletproof. But the concept is good. Together with our friends at Enexis ELAT, we're implementing this. We are talking to a lot of other charge pole providers, utilities, to build a pendulum charging network, and all this kind of technology is very, very important for us. Next step for us is, so we are setting up right now a virtual representation of a large-scale physical charging system with a lot of charge poles, with a lot of cars, and putting this in a virtual simulation. And every entity in the simulation, every car, every charge pole, has an identity on the real-world tangle. And by kind of doing the transaction simulation, linking this to our IOTA backend, so we can demonstrate that this type of system would work in the real world if charge poles, cars are available. And we are now testing in terms of scalability, how does it work, and how does it feel to do this. That's one of the next steps, to do this, to do a simulation of a physical system, but to connect it with real-life transactions on the IOTA tangle to demonstrate these kind of concepts in a more scaled, simulated environment. That's what we do in addition. So innogy is doing venture building. So we have built Share and Charge. You probably saw this. 1,300 charge poles all over Germany. Puts this on the Ethereum blockchain. So we set up a venture called Motionwerk that's now taking care to continue develop technologies, platforms, engage with customers from other utilities and automotive industries to build a decentralized platform. And one of the big visions we have, it's not a big vision anymore because we have a couple of people here from Netherlands, from Scandinavia, from France, from Belgium, from Czech Republic, Poland, a couple of other countries. And we are now bringing our charge poles as utilities on the blockchain. And this is what we call applied ecosystem innovation, because we don't want to dominate the blockchain as a single company. So we do open ecosystem innovation and collaboration with a couple of other people, because in the end, this technology is built upon distributed ownership and will not be dominated by a single player. And for that reason, we do it in this ecosystem approach right from the beginning. That's the underlying idea. In the end, in terms of what we would like to do in the mobility area, connecting mobility devices, electric energy devices, and urban infrastructure to build an open mobility system. And we're looking, of course, in a couple of different technologies, but also IOTA is one of them. Yeah. Good. Yes, that's now what we have to say about CarPass, mobility, IOTA, why we love it, and the fourth industrial revolution.
I wonder, what do you think will be the most important thing or the most harder part to get to the technology to working and really prove that it's working? Or will it be more difficult for people to understand the concept that suddenly your car is going to pay itself for fuel or whatever? So it's more, what do you think is more difficult, the technology thing to do or the social part to convince people that this is actually useful?
I think the social part over the last 2 years, a lot of people educated corporates, including myself. So we spoke to automotive suppliers, automotive manufacturers, to logistics, manufacturing people. And I think a lot of people understand it, even understand it on board level. And I think most people understand. And right now I think the topic blockchain and decentralized platform is on board level or as we speak right now, which is very important for Germany because we don't want to be second. It's important that we're one of the very first movers. We have a big industrial base. My personal view is these types of technologies, we have to blend them into our industrial base to stay competitive with the Chinese, because the Chinese are investing billions of US dollar, buy all the kind of technology together right now to go for Chinese supremacy. And we can only counteract this by kind of doing a little bit of ecosystem innovation, educating the board members, opening up the checkbooks, and blending in this type technology into our industrial base. And I think it's working pretty okay. A lot of senior people understand it, get it, would like to do prototypes, would like to work with startups, push the decentralized idea forward. That's my opinion. What is harder in terms of technical implementation, so this is not a Zalando shoe shop, it's not Facebook, it's not Bitcoin, it's Zalando shoe shop, you can easily open this on Amazon Web Service. Facebook, 3 guys in a box could develop it and at the university kind of do some marketing. Wasn't too difficult. Bitcoin is fully digital, so the network effects kicked in very fast. What we're talking here, combining blockchain and IoT, is a little bit difficult because, we have to have the protocols. The protocols have to be really safe because human life might depend on it. And in addition, so we have to push the protocol into actually hardware, into IoT devices. And this piece of adoption, I think will take some more time. However, the good news is what we do with charging. In principle, we can bring a node in each single charging pole. As innogy, we own approximately around 1,300 charge poles. We're operating more. Some of them are owned by our subsidiaries. Let's say we have the 1,300. It's a fleet of charging poles. We could decide to bring in a node in every charging pole, or we bring one node in our data center, there's a communication gateway, and by connecting the communication gateway that's connected to all charging ports via Deutsche Telekom or Vodafone mobile communication networks, we bring the entire fleet of charge ports in one sweep on the blockchain, and that's what we can call retrofitting. I think, okay, philosophically, we need to bring it in every embedded computing device, maybe even in every sensor, or register every sensor, however we do it. It's very difficult, but doing a retrofitting approach, we can move very fast, and okay, you have to trust a little bit of remaining infrastructure. I think it's acceptable to drive the technology forward and make sure we stay at the innovation edge. That's my view. Yeah.
This question comes as an investor. I have tokens of IOTA. This past week we talked with the IBM people. They working with a program called tangle. It works regulating providers and consumers of electricity to keep the grid working when the demand is high or low or whatever. So I was. My question is IOTA do any approaches to IBM to use the token as a way of paying back and forth suppliers and everybody that has or has any interaction with the grid, with the whole automatic system, and it uses the blockchain technology. So I'm trying to look for my investment, so that's why I'm asking you.
You answer the IBM question.
It's a fair question. As far as I know, actually I do not. At least there's nothing I can tell you that hasn't been revealed yet. If there has been something that has been revealed, sorry. I know where you're coming from, but it's not up to me.
So I think, let's say 18 months ago or 12 months ago, I had a call together with the IOTA people and the IBM people. At this point in time, IBM was interested and they understand it, but they cannot do everything at the same time. Yeah? I think it will come somehow. This would be my. However, the question you raised in terms of the energy grid, there's huge volatility with all the renewable power sources. Then, of course, it's called in the energy language so-called flexibilities. A flexibility is basically something where you can change the power consumption, or can load shift the power consumption to a different point in time, or even can extract some energy. A basic concept of flexibility is a battery. And what the grid providers are very interested to get access to flexibilities, such as batteries, such as fridges, such as supermarkets, cooling devices, melting furnaces, whatever it is. And if I then can connect the flexibilities, aggregate them, then I can link this aggregated flexibility to my grid control system. If there's too much energy in the grid, I basically charge the flexibility. If there's less energy, then I discharge the flexibility. And of course, with this are purely machine-to-machine transactions, and doing this with a cryptocurrency would be perfect, because then we get rid of all the expensive SAP systems, settlement systems, billing systems, master data, and all the people who have to maintain the master data. We get rid of this because directly machine to machine, and that's one of the key concepts we are looking into. We are also looking into kind of a concept where I connect a new flexibility. Let's say a substation can identify that the new flexibility is being connected. It's validating the flexibility, which means so how much energy can it store. It's sending a signal to it, controlled signal, measuring the response, what is the response time, and by validating it, aggregating it, then I have a portfolio, a quality portfolio that I can sell to the grid provider to stabilize the grid, and this is a huge benefit. Yeah? And that's exactly the use cases we look into as utility, and of course this technology might be useful for it. Yeah?
All right. So, any questions that are not related to crypto speculation or insider information?
Insider information, yeah.
My question is, do nodes consume any energy when they are verifying a transaction on the Tangle?
So what kind of node are you talking about? That's probably my best question to you, because it really boils down to that. If you've just got some IoT device that's probably not going to be running a full node, no. It will do proof of work, probably. It might offload that to some other node. If it does proof of work itself, of course, it will consume a certain amount of memory, power, but we're working on optimizing that to get away from the CPU-bound energy requirements. Other than that, like the full nodes, just when they receive a transaction, the only thing they mostly do is they validate that the proof of work has been done properly, and the rest is eventually up to the network, and for when eventually the transaction will be confirmed.
Yeah, so in principle, there's a light node option for IoT devices, which doesn't consume much energy. I don't know the benchmarks right now, but it's not much energy. And what's also worth to know is that IOTA has a vision to go for ternary business logic. Today we have binary, 0 and 1s, and then we have 0, 1, and unknown. That's good for the cryptography. That's really kind of a value add ternary business logic to move to better cryptography. In addition, if I have a ternary chipset, it can be smaller. Transactions are much more efficient and uses even less energy. And it's kind of a vision to kind of have very, very light devices attached to an IoT device that doesn't have much energy to do its operations. Yeah. It's a lot of innovation going on there. Yeah. Very nice.
Yes, there's definitely lots happening there.
So what's the status of the hardware hashing? At least I think you raised some money, I guess.
Well, what kind of hardware hashing are we talking about? Are we talking about that ternary implementation?
Yeah.
That magical ternary implementation? It's mirroring something definite.
Okay.
It's not vaporware. Yes, that I can definitely say. It's certainly real.
It's nice. At least it's nice. I recommend to you look into ternary. It's open up your mind.
I mean, we're not the first.
No.
Maybe let me just say like that. We're not the first to go down the ternary route. There has been research done there in the past. We're not trying to do something completely new that hasn't been done before. We'll see where this goes.
That was a pretty confident smile.
Yes,
No,
I am actually.
I think it's an old concept. Russians built some prototypes a couple of 10 years ago, but now I think the IOTA people have the courage kind of to again look in the concept and push it in reverse. Yeah? Someone has to do it. Yeah.
All right, more questions?
Andreas, you mentioned briefly that you are working on a plan to open up and make industrial data accessible. That sounds pretty cool. Can you tell us a little bit more about that? Please.
So much leaks that are being requested. So in the end, it really boils down to what I said before. Is essentially it will be a platform that will be released next month, where companies will provide interfaces for being able to sell data of hardware that you own on this platform, so that you can then purchase this data using the tangle, and also to be able to retrieve the data using the tangle.
For me to understand the IOTA blockchain a little bit better, you said the wallet actually calculates the transaction. So the node is actually the wallet, and where is the actual blockchain then? If I want to look it up, how does it work in IOTA?
Okay, so not blockchain, we call it tangle. But other than that, so essentially, when you have a wallet, the thing that it does, it talks to a full node, and it uses the connection to that full node across an HTTP interface to request data out of the database that a full node maintains. You can also run your wallet in a full node configuration. And when I said earlier that the wallet computes the transaction, so to speak, what's happening there is if you want to send tokens to somebody else, then when you have a negative value change on an address, then that value change needs to be cryptographically signed. And what's happening there is essentially, the wallet, of course, owns the seed, it owns the private key, and then using that private key, that address private key is derived and then used to sign the transaction. And using that signed transaction, what's happening then, and that has to happen for every other transaction, is that proof of work needs to be done. That means that it's a system similar to Hashcash. Hashcash is this, well, essentially you find a hash collision so that the hash ends in, at the moment it's 15 zeros, 15 ternary zeros on the mainnet. And once that requirement is done, you can publish that transaction to the tangle itself, and it will be accepted by a network.
Andreas, my question is
go ahead.
for you. I'm sorry. Could you lose any words about the recent attack on the tangle, which happened yesterday, I guess? And what exactly the point of weakness was in the tangle, which has been tried to compromise?
Okay. Yesterday. Not yesterday, Monday.
Not yesterday.
Yes. So what was happening there essentially is that okay, so they're essentially transactions that are part of the network are at the moment, because the network is still in its very infant stages, because there is not enough hashing power, essentially confirmed by a central entity that we call the coordinator. So what this coordinator does essentially is it releases these milestones to the network on a regular basis, on a regular interval. And what said attacker did is essentially he did not break any cryptography. He did not, hack the coordinator's private key or whatever. But instead, what happened is that the attacker reused old milestones, so to speak, and using these, by modifying them in a specific way, attacked IOTA, that is the software that runs on the full nodes. And this is actually something. So back in 2015, early 2016, there was a check in IOTA that prevented exactly this scenario from happening, which got optimized away by when we tried to become a bit more efficient over the past year or so. And essentially, so what then happened is, if you looked at IOTA back then, a few days ago, before we released our latest version, you could see some abnormally high milestone number. And that essentially was just IOTA getting confused about what the correct number is. And that's essentially all that was necessary to fix that, was just to tell IOTA, update to this version that ignores this bad milestone, and revalidate all the milestones that you have, so that you can be sure that you're on the right milestone, that all the transactions are in the correct order and approved correctly.
To get this right, the aim was to convince the coordinator to propagate another milestone than just before.
Yes, but that milestone did not contain any transactions that went to be confirmed. Anyway, that hadn't been confirmed in the past. So there were no double spends or anything like that confirmed of any kind. So it wasn't an attack against no funds were stolen. It sounds bad, but no bad transactions, no conflicting transactions were confirmed using that. So essentially, the integrity wasn't violated.
Hi, I was wondering if the machines are going to have kind of like, let's say, like a contract that they say, yes, I want to pay I want to charge this card, for example. Let's say, like, let me put it as an example. Like they say, I want to charge only 4 cars. And Tesla, they say, yeah, I want to charge only Tesla cars. So my car, that is a 4 car, comes to a Tesla charging station, and they have the IOTA, whatever. And then is it able, like, to refuse a payment? And based on what? What kind of rules can you put? Like, let's say, me as a company that I would like to provide a service for charging cars, I could say, yeah, I don't want to provide this service to, let's say, terrorists or whatever, and stuff like this. So I'm wondering, like, what kind of rules and what kind of rules can you, let's say, code in order to accept or refuse these kind of charges?
Basically, you can set up your own business logic. You can set up a decentralized registry, like, let's say, on a blockchain, on a tangle, to register IDs, to put some master data next to the IDs, like, say, this is cars you would like to service, some other cars we don't want to like to service, and then you only accept whitelisted cars. Yeah? That's possible. I think what's interesting, I think it's the other question that's linked to this, if you think a little bit further, because if you're a car, you would like to find a proper charging pole, and then you have to send a request to the decentralized platform, you get some bits back, and then you you log a bit, and you have to log the pricing conditions of this dynamic pricing bidding scheme going on, and then when you go to the charging pole, you exactly can reference to the terms, charge the cars. So it's dynamically bidding involved as well, and that's very nice. Yeah. Now we go to Rob. And then we go back to you. Let's go first to Rob.
I will pass you right. I was in line.
Okay.
But if you want to go first.
It's almost a running joke.
It's in the same field. It's in the same field of his question, actually, regarding the business model of this digital twin approach. We've been talking about car fleets where you don't really own the car, so there is an owner that is in charge of managing your wallet, let's say. But how do you see it going, the trend? Let's say I buy a car that has a IOTA wallet inside. Will I own the wallet, or the wallet will always be belonging to the factory? That at any time can just...
No, so if you own the car, in principle you also own the wallet. Yeah? You can also give it back to the factory in principle, yeah. But in the standard setup, you own the car and the wallet. What Tesla is doing, regardless of blockchain, they are preparing with autonomous driving that people can rent out their cars. So if they don't use it, cars are doing ride sharing. Cars or transportation services, Tesla cars are being aggregated in a fleet, and they approach it from a technology side, autonomous driving, and they approach it from a legal side. They already put now terms and conditions in the contracts with the Tesla car owners that this will be possible in the future. I think this is being prepared, and the only thing is missing it's a digital wallet. Yeah. So we personally believe in the end there are scale effects. There will be fleets of autonomous cars or autonomous vehicles that are electric and shared. It's called faves, and the fleets are then going through the cities, and the ownership of the faves will be totally dynamic. Yeah? So people might have ownership tokens in the fave and trade them, buy them, sell it to Argentina, whatever it is, whoever has a benefit owning the faves, who probably has some algorithms to optimizing the EBIT being produced by the faves, whatever it is. Will be very nice, and ownership will completely change.
So the Tangle technology is really interesting. I have a couple questions for Andreas, which are closely related. So the first is, in a world beyond the coordinator, when it's fully decentralized, could you talk a bit about the incentive structure? First, what incentives do participants have to participate? And furthermore, that it creates a structure in the Tangle that has a consistent view of transaction ordering and balances being spent. The second question is, how do you reason about transaction finality in the Tangle, whether a transaction is likely to be reverted?
Okay, so maybe let's start with the second question, actually, because that's a bit easier to answer. Transactions, right now, as soon as they're confirmed, are final. It boils down to that. There's no malleability. We can't control that. That's it.
It could be on like a very small minority, which is eventually overwhelmed. Like, let's say it has an ancestor, and then the prior ancestor of that transaction, like the grandparent, is then built on much more than the one that your transaction was built on. I mean, it's an eventual finality because it's a proof of work system that you converge to finality. But if nobody else builds on top of your transaction, it might as well have never happened.
That's correct. But then you can actually reattach that same transaction in another place so that the chances of somebody else confirming your transaction by doing proof of work using your transaction is higher. Like, I mean, there's some the tangle grows in the direction of time, if you want to call it that way, even though it's a kind of multidimensional growth. So, so there is some temporal order to things, and the further into the future or into now that your transaction is attached, the more likely it's to be confirmed, and also the more likely it's to be accepted by a network, so to speak. And this might actually probably answer also where you were going for with the first question, which is essentially if you have, I mean, this sort of boils down to consensus and to let's call it to the weight of transactions. That is, well, you could, for example, say the more transactions that reference a previous transaction indirectly or directly, the higher that transaction's weight becomes. So as a network, you might say that if this transaction is not conflicting with my ledger state, so to speak, that is, with the state of all balances, then the higher that transaction weight, the higher that transaction's weight is, the higher the probability of that transaction being accepted.
It's not just like a linear increase in weight, because you could imagine the tangle diverging in two places. In one, I send the money to you. In one, I send the money to Carsten. So then one of these branches grows at a rate faster than the other. So the weight is accumulating on both.
So you will need to make sure that your transaction is being confirmed by a network. And that's possible essentially even now already by moving that transaction and attaching it in another place, by doing proof of work again.
So if you consider the proof of work to be a constant cost, so the fee, you can consider it as a fee essentially. When you attach a transaction, you do proof of work. So when you reattach, you're paying the fee again. So this comes back to incentives. So how do you know that there's actually an equilibrium where people will not end up paying fees which have a higher cost than the utility of sending that transaction?
Let me think about a way that I can answer this without giving away too many cards. Maybe do not think of proof of work as a constant, but as something that is malleable in the future.
Well, you mean a difficulty target?
Yes.
But either way, it's still a cost.
Even then, depending on
the cost function of taking that action.
Yes, but if that cost function can be adjusted in some senses, then you can. If you adjust that cost function, then it becomes. Then you might become more incentivized, essentially.
We can continue this afterwards. I'll let somebody
let's do it.
A question.
This is getting very technical. Well, you can do that. We're not going to be offering that. I think on a last AMA I did, I essentially posted off how you could do that. You might just even use AWS Lambda to do that. There's nothing preventing you from it other than that you will need to code it. I mean, even right now, if you want to think of it that way, then there's some full nodes that accept attached tangle calls, which essentially makes the proof of work happen on that node. But somebody else wasn't lying. Somebody has the mic.
Hey, so first of all, thank you for the presentation. My question would be, why is IOTA, being such a big cryptocurrency in terms of market cap, why is it only traded on the Bitfinex exchange? And will it in the future be traded on other exchanges as well?
If it were up to us, we would be on quite a number of exchanges right now. It is not, unfortunately. There is some, like this week, next week, I can tell you, this month, super likely. There's some places finalizing their implementations, and the reason for that is essentially that we're quite different to implement, simply because exchanges need to do far more input management and also need to keep track of many more things than they have to do with Ethereum or blockchain or any of those gazillion tokens that run on top of Ethereum.
You spoke about identity. So my question is, can identity be transferred? Because you spoke about private keys or something of that sort.
So it depends where you store your public-private key pair. if you transfer the private key to somewhere else. On the regular blockchain, you can do this, and not sure about IOTA.
Yeah, you can. Well, essentially, a seed is just 81 tries, as we call them.
Okay, so what's going to stop someone from taking that identity? Let's say I have 2 cars. One is a used car, really, really used, and the other one is a brand new car. And I want to sell the old one. What's going to stop me from transferring the private key onto the new one?
Yeah, what you basically do, today you store private keys, so-called secure elements or crypto chips. You generate a public-private key pair, public-private key pair. The private key stays fully protected in the crypto chip. The public key is being, let's say, published on the blockchain. And with the private key in the crypto chip, there are no ways kind of to physically get it out. With side channel attacks or with raster electron microscopy, a couple of attack vectors are there. If you want to do that, it's super expensive, but you just cannot get it out. Yeah.
Okay. Yeah, it pretty much boils down to there's chips that will delete the key if you hack them or if you try to hack them and they notice it, and it's also super likely that the effort is not worth the reward in this case.
Yeah. And what's also interesting, so in Germany, the leading companies building the crypto chips is NXP. They're based in Hamburg, and it's Infineon, so it's another part that we have in our ecosystem, yeah, to put these crypto chips into action. Yeah. And by the way, they're in every credit card in this kind of system, so it's cheap, you can use them, and it's available technology.
Okay, you also said about a transaction that's going on from one machine to another. And let's say, the one machine gets broken in the course of the transaction, and that means you have to the transaction can't take place anymore if you replace that machine with a new one, because the other machine it's expecting say some particular hash or whatever you're using to identify it, because the new one comes online now and gets assigned a new private key. So it means that communication can't continue anymore.
That depends on the business logic of a decentralized platform. I think one aspect is, can I transfer the money from the old machine to the new machine? And of course you can do, so in regular blockchains you work with multi-signature wallets, and if you lose one private key, the other keys can still sign a transaction and move money. So that's possible. And of course, depending on the business logic of your platform, you can allow to sign up new machines to interact. Yeah.
I guess we all agree that adoption is the most important success factor for IOTA. So can you elaborate a bit about why companies should use IOTA instead of our own Tangle? Because, well, you provide the technology, and adopting the technology is one thing, adopting the whole public coin is another one.
Right, so why should I use the public network? Essentially because if you do not, if you were to run your own Tangle, leaving the issue of confirming value transactions aside, just really leaving that out of scope. I mean, if you only run your own Tangle in your own company, then there isn't that much use to you, because the way most companies are envisioning using the Tangle right now, or are using the Tangle, is essentially by transferring trust to a third party that nobody can control, because there's too many nodes that have converged on a specific state and share the same state. Now, if you were to just have one company running set of nodes, then whoever they're interfacing with using that Tangle would have to trust that company. And then that would just be keeping the status quo of data silos and having permissioned issues.
Yes, your point, but imagine all German car manufacturers join and come up with their own Tangle. So I imagine they trust each other more than they would trust the public network.
Why? I'm really going to ask you why here, because yes, but if everything's encrypted, if nobody has got any information to glean from that, why should they be trusted? Well, why should they trust each other more? Or let's take let's take a third party that is probably not going to trust them, or they're not going to trust them. Kraftfahrtbundesamt, the regulatory authority that's essentially certifying cars and controlling cars in Germany, given the unfortunate developments in the car space over the past couple of years, you need to externalize trust there because the existing trust model no longer works.
Anyway, I think if you look in Bitcoin, a lot of Bitcoin forks happen down the road, and I think I wouldn't say it's impossible that people start to fork IOTA and set up their industry domain-specific tangle. I think it's entirely possible. We don't know yet. Let's wait and see.
One would hope that they don't do it, but yeah.
You never know.
Maybe short question to Andreas. Do you consider a wallet ID personal data, so personenbezogene Daten? Because I'm just considering the car use case now, and for example, if you consider cars, you can go for a license plate either. So the license plate is personal data. And if you have a car by yourself and you have a wallet, that could be personal data that's also public to everybody. And you can even imagine that you get the information about the charges quite easily, because they have to be relatively easily officially exposed to everyone, because you have to do transactions. So in the very worst nightmare case, I could know your wallet ID. I could know the wallet IDs of your charges, and then I could even redraw your whole way. And that would be a fear that I would have.
Right, so there's no wallet ID as such. You cannot infer which transactions belong to the same address, belong to the same seed. Which addresses, I'm getting my terms mixed up here. So just other than walking through bundles, there's little information to be gleaned from that. I don't think it's actually personal, because there's no personal data stored immediately just by doing transactions. We do not recommend to store unencrypted data, which, I mean, of course, if I were to store my full personal contact data on the Tangle, then yes, that would be personal information, and I would probably be pretty dumb to do that. So I would argue that nobody should ever do that. I mean, but at the same time, also the same case can be made for pretty much any blockchain, because I think if you look into Bitcoin's past, there were quite a few things stored on the blockchain that shouldn't become part of such things, but that's just the way things go.
Thanks for the mic. I don't know if it's a stupid question, but do you have any plans on integrating a Turing-complete machine on top of the Tangle?
A Turing machine on top of the Tangle, you mean in the sense of smart contracts, yes. I guess. Stop laughing. Well, there will be something like that, yes.
That's great.
That's great.
No, that's going into speculation now.
I got a question about the speed, basically. We're talking about charging a car and transferring money at the same time. Just now we saw one transaction was about a minute or something, but it ran through the DBD, a big DB, right? And now the question with Flash, it's Flash, right?
Yes.
How quick will you be? Could I theoretically?
As quickly as you can generate that transaction. There's an unlimited number of parties to a Flash channel, essentially, and each party co-signs a bundle. And so there's, in addition to the transactions that form a bundle, there's also a settlement address in case some party should betray the other one, or if both parties should not agree on what's happening, then the party that's being offended or whose rights are being violated could just attach the bundle to the Tangle, and thereby that channel would be closed, and you would then have all the funds stored in a settlement address where two parties could then decide on. Where those two parties could then decide later on how they will solve the situation.
So it's similar to Plasma? Yeah, Lightning. Yeah.
In a bit, yes. Yes.
I mean, speed-wise.
Well, speed-wise, I would argue that it's maybe even faster, because you don't necessarily have to have something in between. You can.
Just as a product manager, when do we see these products coming out? So, I mean, we saw that it seems to work, the transactions. When can I charge my car paying with IOTA?
Today we can pay on the Ethereum blockchain with crypto euro and with IOTA. So we put it in our development roadmap, but we don't have a.
How would that work? So I have an Ethereum wallet and I go to a charging station of Innogy and.
Yeah, today it works like this. What you basically do, so we have an app, that's a share and charge app. You find it in the App Store, you can download it. And then there's a payment gateway where you kind of transfer euro from PayPal, your bank account, into crypto euro, which is basically ERC20 token on the Ethereum blockchain. And then you can do your smart contract transactions to charge your car today.
That's already working?
That's working, yeah. Okay. With the 1,300 charging poles, yeah. And now we are also kind of building it, so it's working on the public Ethereum blockchain. Next step would be to do a minimum permissioned Ethereum blockchain, and then as a further next step to blend in technologies such as BigchainDB and IOTA to continue grow the platform. And what the colleagues from Annexus and ELAT are doing, it's a prototype, and I'm not sure when they have a product in place, but probably not. The prototype and the product with all regulatory issues solved. A prototype, next month. And of course, when you build products, you have to think about financial regulations, some legal topics, and so on. And that's another big part. Yeah. But I think with IOTA, maybe the next year, we see somewhere that people put a real product in the world. Yeah.
Yes, thank you for the presentation. And my question is about the control. So I always listen and yes, we are decentralizing everything. And what I understand is the financial system is controlled by central banks. If we change the control here to this IOTA system, so we change the control to the people who are running the programs, although it looks like it's decentralized. And this is the first question. Second is we are not giving more control and the corporates, because they know more what we do. If I scratch, they can get the information. Yes, that's the questions.
So I think I really like the question, because today we have the central banks. The central banks are doing financial engineering, and we have the banks, and they manage all of this. If we look in the crypto world, you have a protocol, you agree on the protocol. So in some cases, there is no further mining, such as IOTA. There's a stable money supply. In some other cases, such as Bitcoin, the protocol, there's the mining rewards and the 21 million in the end. So the control is being defined by the protocol. However, people also talk about trustless systems, but the trust is not disappearing at all. So there's still trust in the cryptography, in the mathematics, and the people who are implementing this. And so trust is not gone away, but in the end, there's a protocol, and if you trust it, then we get rid of the big central banks. Yeah.
Yes, and the second question on that is, you say, well, we are joining forces in Europe to decentralize and work all together because of the Chinese are coming. So my question is, okay, that is great. So we are not just joining all together because it's a good thing, because we have fear.
It's a good thing.
Yes, because we have fear of the Chinese, and the question is why we don't join them.
Oh, we can join them as well, but
it's like.
So in the end, I think in the end what will happen. So we have this fourth industrial revolution. A lot of jobs are being cut away. Yeah, fully. I think we lose a lot of jobs. Yeah, because everything is automated. And the question is, how do we stay competitive? And of course, we can join the Chinese, and if we have to do this to define standards and to implement global quantum key distribution systems, whatever we do with the Chinese. But in the end, I think it's on us to really stay competitive, to be this tip of the spear in terms of all of the innovation, to have a decent life, I guess. No?
Thank you very much. Thank you.
But there was another question, wasn't it?
All the way in the back.
A trust.
So yes, I've been following you guys for quite some time. Holistically, are you guys looking at integration for smart cities?
Come again, please. I understood smart cities and holistically.
So integration, IoT throughout cities, actually, a lot of the digital components, having that integration and coordination. Are you guys looking like long-term kind of, I know you guys have different verticals you guys are touching on right now and you guys have to prototype, but long-term vision, looking ahead, are you guys looking to implement your technology with smart cities?
You know, I actually don't think that there's necessarily that much difference between M2M and smart cities, because smart cities is just an application of M2M. In some other slides, not sure if they're available, we also have an image of a smart city. So yes, it goes in the direction of our thoughts, and who knows what's going to happen there in the future.
Hello. I had you guys both. First of all, both of you, thank you. You both mentioned a lot of tagging of machines and tagging of assets and goods and putting them onto the network on the blockchain. How exactly should I imagine this? Are we talking about QR codes or crypto chips that you mentioned and putting these onto machines and storing information on these and putting them on the network? And how would you do this for goods which cannot be tagged? Or you, for example, mentioned the Adidas shoes. Am I supposed to then imagine that we'll all have shoes with little tags which we can just check on the network, the information, and see, okay, these are real Adidas shoes or not? Or
yeah, it depends on the use case. For example, what has been done with Nike and Adidas shoes, people put in a crypto chip with near-field communication. It's in this part of the shoe. And then with your phone, near-field communication, Android device, you can read out the crypto chip and validate authenticity, for example. I think that's one piece. The other piece is we are doing this actually as well. We are using secure QR codes that are printed out by printer and with a very tiny structure in the middle. The tiny structure depends on the imperfections of the printer. And with these imperfections that you cannot copy, you can at least give it an identity that's not clonable. And yeah, all this kind of blend of technologies from secure elements, crypto chips, blockchain software, to kind of tagging with secure QR code, that's something, depending on the use case, that's being applied.